In 2017, astronomers detected something extraordinary that changed everything. An interstellar object, later named Oumuamua, entered our solar system.
To go there and find out.
It was discovered on October 19, 2017, moving fast, strange, and completely defying expectations. 2 years later, in 2019, a second interstellar visitor, Comet 2I Borisov, was discovered on August 29, 2019, confirming that Oumuamua wasn't just a cosmic fluke. Now in 2025, it has happened again, but this time, we're ready like never before. On July 1st, 2025, the Atlas telescope at Rio Hurtado, Chile, spotted something that immediately raised eyebrows in the astronomical community. Initially catalogued as A11PL3Z, this object first appeared on the Near-Earth Object Confirmation page, flagged for urgent follow-up observations. But the moment astronomers began plotting its trajectory, the signs were unmistakably clear. This object isn't from around here. Unlike Oumuamua, which we caught 40 days after it had already passed its closest point to Earth, this time we detected our cosmic visitor while it was still approaching. We finally had the luxury of time, something that had eluded us with previous interstellar objects. The object's orbital path is sharply hyperbolic, with an eccentricity of 6.15 plus or minus 001, the highest ever recorded for any object passing through our solar system. To put this in perspective, anything with an eccentricity greater than 1.0 isn't gravitationally bound to the Sun. This object is moving at 61 kilometers per second relative to the Sun, fast enough to circle the entire Earth in under 11 minutes. But speed isn't the only thing that makes this visitor extraordinary. The size estimates range widely due to its active coma, but the nuclear diameter likely ranges from 0.8 to 24 kilometers, potentially making it significantly larger than previous interstellar visitors. The International Astronomical Union's Minor Planet Center has now officially catalogued it as 3I Atlas, the third confirmed interstellar object in human history. To understand why 3I Atlas is so significant, we need to look at how dramatically different each interstellar visitor has been. Oumuamua was the mysterious trailblazer. Discovered on October 19, 2017, this elongated, tumbling object roughly 100 to 1,000 meters long showed no signs of cometary activity, despite accelerating in ways that couldn't be explained by gravity alone. Its reddish color and unusual properties sparked debates that continue today. 2I Borisov was the familiar one, discovered on August 29, 2019 by amateur astronomer Gennady Borisov. It behaved exactly like the comets we know, complete with a classic coma and tail. Chemical analysis revealed compositions remarkably similar to solar system comets, but with intriguingly high carbon monoxide concentrations. Now, 3I Atlas appears to be writing its own chapter entirely. It shows clear cometary activity with a detectable coma and tail, but its activity level is surprisingly weak for such a potentially massive object. Preliminary studies suggest it could be 4 to 7 billion years old, potentially making it older than our entire solar system. The story of how we found 3I Atlas showcases just how far our cosmic detection capabilities have advanced. The original discovery came through the Atlas Survey Telescope at Rio Hurtado, Chile, but within hours, astronomers were digging through archival data and found earlier images of the object stretching back to June 14, 2025. Over 2 weeks before the official discovery date. This kind of data archaeology is now routine. Pre-discovery observations were found in Zwicky Transient Facility observations from June 14th to 29th, 2025, and additional Atlas observations from June 5th to 29th, 2025. The confirmation process moved with unprecedented speed. Within 24 hours of the initial detection, multiple observatories around the world had confirmed the hyperbolic trajectory. By July 2nd, 2025, observations by the Deep Random Survey in Chile, Lowell Discovery Telescope in Arizona, and Canada-France-Hawaii Telescope revealed clear cometary activity with a coma and 3 arc-second tail. The James Webb Space Telescope represents a complete game-changer for interstellar object research. When Oumuamua passed through our solar system, JWST was still years away from launch. When Oumuamua Borisov visited, the telescope was still being assembled. Now, for the first time, we have a cosmic visitor arriving during JWST's prime operational period. Webb's infrared capabilities spanning 0.6 to 28.5 micrometers can detect molecular signatures that are completely invisible to ground-based telescopes. We're talking about the ability to identify water ice features at 2.7 micrometers, carbon monoxide at 4.67 micrometers, and complex organic molecules that could reveal formation conditions in alien star systems. The telescope's mid-infrared instrument can operate at wavelengths up to 28 micrometers, allowing it to detect thermal emission from the object itself. JWST can track objects moving up to 100 milliseconds per second, more than sufficient to keep 3i Atlas in its crosshairs throughout its passage. 3i Atlas is providing us with an extended observation window. The object will reach its closest point to the Sun, called perihelion, on October 30th, 2025, at a distance of about 1.33 astronomical units. That's just inside the orbit of Mars. However, the object's closest approach to Earth comes on December 19th, 2025, at a distance of approximately 1.75 astronomical units. While that might sound distant, it's close enough for both ground-based and space-based telescopes to conduct detailed studies. During its approach, 3i Atlas will pass within 30 million kilometers of Mars on October 2nd, 2025. The object is currently visible at magnitude 18.5, requiring telescopes with 150 to 200 millimeter apertures for imaging, though it may brighten as it approaches the Sun. While JWST will provide unprecedented detail about 3i Atlas,
the Vera Rubin Observatory is in Chile and uses the world's largest digital camera.
the bigger story lies with the Vera Rubin Observatory, which achieved first light on April 15, 2025, and released its spectacular first images on June 23, 2025. Named after the astronomer who provided the first convincing evidence for dark matter, this observatory scans the entire southern sky every 3 to 4 nights. Its 3.2 gigapixel camera can capture images covering 3.5 degrees of sky, wide enough to fit 7 full moons side by side. The revolutionary capability. Rubin can detect objects as faint as magnitude 24.5, making it capable of spotting interstellar objects that are 10 times fainter than current surveys. Computer models predict it will discover 1 to 70 interstellar objects per year, once fully operational. Already, in just 10 hours of test observations, the observatory discovered 2,104 never-before-seen asteroids, including 7 near-Earth asteroids, none of which pose any danger. This compares to approximately 20,000 asteroids discovered annually by all other observatories combined. Modern survey systems employ sophisticated algorithms that automatically distinguish between the millions of asteroids in our solar system and rare visitors from interstellar space. The mathematical criteria center on orbital eccentricity greater than 1.0, which indicates hyperbolic trajectories originating outside our solar system. Machine learning systems process terabytes of nightly observations, analyzing position, velocity, spectral characteristics, and orbital dynamics. These AI systems can identify patterns that human observers might miss, dramatically improving detection efficiency. For 3i Atlas, by the time it was announced, the Minor Planet Center had collected 122 observations from 31 different observatories. The integration of multiple survey networks creates a global detection mesh. 3i Atlas presents unique scientific opportunities. Its hyperbolic excess velocity of approximately 60 kilometers per second and 175-degree orbital inclination suggest it originated from the thick galactic disk. The object's incoming trajectory from the constellation Sagittarius, near the galactic center, differs from previous interstellar visitors. Recent spectroscopic observations show the object exhibits weak cometary activity despite its potentially large size. Observations confirmed it was clearly active with a diffuse tail. The combination of its extreme age estimates, unusual activity level, and record-breaking orbital parameters makes 3i Atlas a unique laboratory for studying ancient interstellar material. Current population estimates suggest approximately 10,000 Oumuamua-sized objects pass through the inner solar system at any given time. Research indicates that interstellar objects may actually outnumber solar system objects in the outer reaches of the Oort cloud. 3i Atlas, with its apparent extreme age, offers a particularly tantalizing opportunity to study material from the galaxy's early stellar populations, ancient material that formed when the Milky Way had very different chemical compositions than today's stars. The study of 3i Atlas showcases modern astronomy's collaborative nature. Within hours of discovery, observatories across continents began coordinated campaigns. Ground-based telescopes from Mauna Kea to Chile contribute different pieces of the puzzle. The European Space Agency's Comet interceptor mission, launching in 2029, represents the future of interstellar object research. Additionally, Hubble Space Telescope observations are planned for July 21, 2025, with zero proprietary period to maximize scientific benefit. As we watch 3i Atlas make its passage through our solar system, we're witnessing the beginning of a new era in astronomy. The convergence of revolutionary survey capabilities, artificial intelligence, and unprecedented infrared spectroscopy creates opportunities that were unimaginable just a decade ago. Within the next decade, the discovery of interstellar objects will become routine, with the Rubin Observatory potentially detecting dozens per year. We'll have detailed chemical inventories of material from multiple alien star systems, potentially revealing signatures of habitable environments. 3i Atlas represents more than just the third confirmed interstellar object. It heralds an era where visitors from other star systems become regular subjects of detailed scientific study rather than rare, fleeting mysteries. The universe is delivering its secrets directly to our doorstep, and for the first time in human history, we have the tools to unlock them. Each new discovery brings us closer to answering one of our most profound questions. What kinds of worlds exist around other stars? And could any of them harbor life?